let's go through LeetCode 549, binary tree longest consecutive sequence is 2. For this question, we give us a binary tree, and let's find the longest consecutive sequences. So that means what is the longest consecutive sequences? Is that from any node to another node, the connections has a sequence which is consecutive. And um, it can pass a route. So can be it can so what we think about is for a tree, right? Those kind of consecutive may have three options. One is it is coming from its left child, the longest. Another is from its right child tree, and the third is that it is possible there is a candidate coming from here, right? Coming from this root. So doing this analysis, we can think about post-tree traversal or divide conquer, right? So, but pass a route, there are two possibilities. One is it is, for example, increasing, or I would say, for example, 3 to 1, whatever, or 6, 5, 4, right? So from root to here, that is increasing, and from root to here, that is decreasing, right? This is one options. Another options is that from root here, this is increasing, and from here, this is decreasing, right? So what we need is that for every tree, we should also record two values. One is longest increasing to root. Another is longest decreasing to root, right? We can say from root, longest increasing from root, and the longest decreasing from root. And so for its left child and the right child, if this value has just one value differences, right? So for example, this 5, this 4, then the longest from root increasing, we can add 1, right? And here, if this one is 3, right? The longest from root decreasing, we can add 1, right? So that will be one candidate. So the same thing here, right? 4, 5, 6. If we find this one is smaller than 5, for just for one item. So the longest increasing, right? Add 1, right? So and 3, 2, right? We'll find the longest decreasing item. So that will be two candidates, which also may contribute to our result. So let's write code for this, right? So we need we can write, for example, int result equals to DFS root, and what we return result there, right? And private int DFS tree node, right? Here. So we'll see result 0 will be the longest continuous consecutive sequence in node, right? In tree node. And result 1, this will be longest increasing sequence from root, from node to any leaf, right? And also we'll have result 2 will be longest decreasing sequence from node to any leaf. Okay. So if this is null, right? If node equals null, we just need to return new int s0, 0, 0. Okay. So we can have mm, let's have a result, right? Result equals new int 3. And let's have a left result equals DFS node dot left. And right result equals DFS node dot right, right? So we can have int left increasing from root equals 0, left decreasing from equals 0, right increasing equals 0, right decreasing equals 0, right? Then what we have is that we can check if it's left child is null or not, right? You're saying so to actually we can to check if it is not null, we can also write this one down equal to 0, right? This is all you can write if node dot left is not null and node dot left dot value uh -1 equals node dot value, right? Then we'll have left increasing equals this one. Okay. And we'll write if right increasing, let's also right increasing and right. So we'll have right increasing equals right increasing 1. So we'll see actually result 1 will be max left increasing and right increasing +1, right? Why we need +1? Because for every node itself has add 1 length, right? So similar code of here. So if this 2 doesn't and this will be added, right? Because this will be decreasing. So we'll see left decreasing for this 2. And if this right decreasing to down equal to 0, and it's smaller, right? So we'll have right decreasing equals this 2, right? So we'll have result 2 equals max in the right decreasing +1, right? So what about the result 0, right? So it has 4 candidates. Result 0, it will be max um left the subsequences from the left subtree, right? And also max dot let's do this. And also from its right, right? And also what we need is max dot max is left left increasing plus right decreasing and left decreasing plus right increasing +1, right? So we should have max of these two parts. So this one also needs to +1, right? Because there is one more length from to its to the node, right? So in the end, just return result. It is a ON time complexity with OH space complexity. And let's also write a Python code for this. We should have a result equals self that DFS root. Okay. Then we're going to have return result 0, right? Then we define DFS self node. This is the optional tree node return void, right? So if node is none, then we're going to have return 0, 0, 0. Okay. Then we're going to have left result equals self dot DFS node dot left. Right result equals self dot DFS node dot right. Then we're going to have longest equals max. Let's don't do this. Let's have left increasing equals left decreasing equals right decreasing, right increasing, so right decreasing equals 0, right? So if node dot left is not empty, right? So say if node dot left dot value equals node dot value minus 1, then we're going to have Li equals left 1, right? And I'll say if node dot left dot value equals node dot value plus 1, then we'll have LD equals LR2, right? So we'll say if node dot right, we can also write if node dot right dot value equals node dot value minus 1, right? Then we'll have right increasing equals right 1, right? And we'll write if node dot right dot value equals node dot value plus 1, we'll have right decreasing equals right 2, right? So we'll say, so we'll say there are, we need to have this part, right? Increase equals max left increase and the right increase plus 1. And decrease equals max left decrease, right decrease plus 1, right? And the longest will be max. So we can have from left child, right child, and there is left increasing plus right decreasing plus 1, and left decreasing plus right increasing plus 1, right? So in the end, just return longest increase, decrease.